Hi everyone, Mr. Neighbor here, and today we're going to talk about proportional relationships. And I want to look at the very first word, proportional. Proportional comes from the word portion or part. You're looking at a ratio of things, part of something to the whole of something. So we talked about this when we were looking at percents, where you have a part out of a whole thing. And proportions are always going to be that part out of a whole or part out of something else. It's going to be something divided by something. Maybe you want to write it differently. Maybe you write it as the whole thing to the part with these colons, or maybe instead of that, you write the word to instead. But either way, it's a fraction, it's a ratio. So when we're talking about proportional relationships, we're looking at a bunch of different fractions and seeing if they're the same. If they're all the same proportion, then it's a proportional relationship. So let's look at this case that we have over here. The number of cases they order of paper towels, we assume, to the number of rolls of paper towels. So let's look at all these different proportions. So the first proportion I'm going to look at is 12 to 1. This divided by that. Okay? Then I'll look at the next one, 36 to 3, which if I divide both these numbers by 3, I get out 12 over 1. Notice they're the same. Then I'm going to do 60 divided by 5. Notice I'm always doing the right divided by the left. When I do that and divide 60 by 5 and 5 by 5, I still get out 12 over 1. And if I do 120 over 10, that will also simplify to the fraction 12 over 1. The fraction is always 12 over 1, so this is a proportional relationship. Now, I just chose to do the right divided by left, and there's a reason why, which we will encounter later. But if you do the left divided by the right, it still works out to be the same, except your fraction now is going to be 1/12. It's going to be 3 over 36, which simplifies to be 1/12. And it works out to be the same all the way down. 5 over 60, 10 over 120, all of them simplify to be 1/12 now. So this is an example of a relationship that is proportional. It is proportional, okay? So let's look at another example now. So here we have cups of rice to number of people. I need to first find what the proportion is between these. So if I do that, I would see 6 to 2. I would see 9 to 3. And oops, I don't have any numbers here, so I can't go any further. Let's look and see what these proportions simplify to be, though. 6 over 2 really simplifies to be 3 over 1. And 9 over 3 simplifies to be 3 over 1 also. So I need to figure out what number this has to be 3 over 1 when I simplify it. One way of doing this is to kind of do a little cycle. What does it take to get from the 2 to here? Well, you multiply by 3. What does it take to get from the 3 to the 9? Well, you multiply by 3. So what should it take to get from the 10 to this mystery number? Multiply by 3. So this number should be 30. And 30 divided by 10 will simplify to be 3 over 1. Okay? And now we have to do the same thing over here. However, I'm looking at something different. I have this one on the right. I want this one over on the left. So what do I have to do to get from the 6 to the 2? Well, I have to divide by 3. Or some people might say times by 1/3. I think most people will say divide by 3. Multiplying by 1/3 is probably the better option, though. I will write divide by 3 for this problem, though. So to get from the 9 to the 3, divide by 3 or multiply by 1/3. Notice this one would also work if I divide 30 by 3 or multiply it by 1/3. I will get out 10. So we have to figure out what 45 divided by 3 is. Well, I could break 45 into the numbers 30 and 15. I know 30 divided by 3 would give me out 10. I know 15 divided by 3 will give me out 5. So combining those back together will be the number 15. So 45 divided by 3 is 15. So my ratio over here, 45 over 15, will be 3/1. So this is an example of these two at the beginning gave me the proportion 3/1. I didn't know what these other last two proportions was. I made this table proportional. A lot of times in life, things work out to be proportional. For example, you buy a pair of socks. Well, when you buy 2 pairs, that number doubles. So it goes up by the same amount. If you buy 2 cans of pop and then you want to buy a whole case of it, that might be an example where the whole case is actually cheaper than the 2 individual cans. And that would not be proportional. A lot of times, though, we work with proportional relationships. So I'm going to put some numbers in this table down here, and let's check and see if that one is proportional. All right, here we go. Let's see if this table of number of spring rolls to number of people is proportional. So I'm going to take the right divided by the left. So that would be 3 divided by 6. And that simplifies to be 1/2. Next, I have 10 over 40 or over 30, sorry, which simplifies to be 1/3. Oop, the proportions don't match. So right away, I know that this is not a proportional relationship. Not proportional. Let's just look at all the other fractions to see how close we were. 15 divided by 40 and 28 over 56. 28 over 56, I know that that is 1/2. 15 over 40 though, let's see what I can divide both of these by. I can divide 15 by 5 and 40 by 5. So if I divide 15 by 5, I will get out 3. 40 divided by 5, I will get out 8. So the only two proportions that actually match are the first one and the last one. So if all the others were 1/2, this would be a proportional relationship. However, it's not. With that being said, if I scroll back up and look at what this value was that always came out, this proportion that always was there for every single case, this has a special name. This is called the constant of proportionality. Proportionality. So this is what we abbreviate and sometimes call the COP, the COP, because we don't like to write all that out. So this is the COP. It has a constant of proportionality. Down here, the COP would be 3/1. Down here, there is no COP. There is no constant of proportionality because the proportion is changing. So there is no constant of proportionality. It's constantly changing, so it can't remain the same. So when we deal with proportional relationships, figuring out if something is proportional is a big part of that. So remember, you're taking a ratio of two things and comparing them. And it doesn't matter what way you compare, as long as you're always comparing the same way. Right to left, right to left, right to left, right to left. Or you can do it the other way, left to right, left to right, left to right, left to right. Just be consistent.